Welcome. We are today talking about how to read code. Something you don't get a whole lot of instruction on when you're in school. It's mostly about writing the code. But when you become an engineer, especially as you become more senior, you end up reading a lot of code. So how to start? There's some different times you might be reading code. You're approaching new code for the first time because you're a new project. You're asked to do a code review for a whole project. You're just starting a new job. When you're doing code reviews, whether that be in total or for a PR. And then we're going to talk about how to go through a code in those mindsets, then what to ignore as long as you can, and then how to give feedback once you've read the code or reviewed it. Just as an example, this is some code a friend of mine wrote for our nonprofit. And I'm going to use it as an example just to illustrate what I'm talking about as we go through. The code itself is not really all that important. So when you're approaching a code base for the first time, as you're seeing this for the first time, what are the first things you should look at? First off, README is always good, especially if they've done a good job of saying how it's used, what other dependencies you have, things like that. This one, kind of, not really. So what next would you look for? An entry point. Where does this code start? If you're in C, there's going to be a main function. If you're in Arduino, these INO files will be where your entry point is. In Python, there'll be a package name.py, a main, or the top of the file. If you're in C# like I used to be, there's always an application or program.cs, things like that. We're in Arduino, so we'll look for setup and loop. If you're in C or C++, you'd look for a main or a main function, just to see what's going on when this code starts. Break down your inputs here, see what other things are there. If we were reviewing this to troubleshoot, we'd say like, this particular code, we were having problems getting the file that was needed to work on keys, and that was in this update ACL task. So updating the file is the problem. So you look for things that relate to that. Sorry, I got lost. There we go. So yeah, when you're brand new to a code, look for these high-level things. What's all included? What are things that are related to the functions? See if there's stuff in the README to tell you what's there. Recent commit history. I'm not going to show you the commit history on this one because it's not extensive, but that will tell you what people have been working on, what's been most important lately as well, if you're new. Looking through the H files to stay pretty high level, that'll give you an overview of what's going on in the code without having to get into the nitty gritty of implementation, just to get an overall sense of how things attach together. So what if you were reviewing a PR? You had a pull request in here, and what things should you be looking for? Differences that aren't white space. In GitHub and some others, there are some options to ignore white space changes, so you can narrow it down to just code changes. Look for comments, look for the requirements that this pull request was fulfilling, just to know what they're trying to do before you start reading. Again, look at individual commits to see how the code progressed. And the comments both in your commits and the code itself as you're going through it. What to ignore? That would be the next thing. Things that are not terribly relevant would be your white space changes, like we said. The identity and experience level of the person who wrote the code. sometimes if you're reviewing a PR, you might be tempted to go, well, it's a senior guy. He knows what he's doing. Just, approve it without reading it. Don't think about that. Review each code with the same level of curiosity and inspection. Coding style, it might not match yours. Please do not get into the bracket war conversation when you're reading code. And then libraries and other external components. Especially if you were asked to review this code, the library they used, reviewing that isn't going to be as helpful as reviewing the code itself and how they used that library. Before I go on to how to give feedback, any other questions on how to read code in specific or things I may have missed? Okay. How to communicate feedback. Don't blame anyone. Appreciate it from a humble position, especially if it's a large code base that you are new to. You don't know why things were written that way. The knowledge that the coder had when they wrote it isn't there for you. So while you may suggest fixes or point out issues, come from a place of being humble and not knowing the whole story. If you're giving a long code review, make sure you give your feedback in order of importance. Keep the nitpick stuff till the very end. Put all the big stuff, the prioritized stuff. What's the most likely to cause problems, the most likely to make big changes or see impact in the code, put those first. Also, keep notes of things you saw in the code as you're going through the review that aren't in the scope of the review because they may become important later, whether in this review, if it's a pull request, or in future ones. And if you have, again, a lot of feedback, you might want to split into priority levels as well and explain why you did that. So things that are directly related to a problem they're having versus general code cleanup would be in different priority levels. So if you were going to write some code, other people are going to have to read it, including you in the future. So what makes your code easier to read? Comments. I know the self-commenting code thing has been pretty popular lately. And yes, you should use write code that does comment itself or give some hints at what it does. But still, have the comments, the doc strings, all of those things in there that will make it easier to read for the next person. Your pull request and commit messages. Each commit message shouldn't be things like fixed a bug, made a change, say what you're changing and why. Make them frequently. That way you can see both the progression of your code, your thinking, as well as separate out the changes that were made, especially if you have to go back and change things later. When you make your pull request, point out what requirement this was fulfilling or what bug it was fixing. Explain why you made the change, other things you may have tried, and what are some important considerations, like what it doesn't fix or what somebody should especially look at. And we talked about readmes, and you saw that one that was pretty small in the example repo. I hope to have a better example here soon. And Joe, I'll have to see if we can pull that one out. Explain what all you have to install to start writing this code, what dependencies you have to download, how one starts, structure of the code, what it's doing, and as much information as you can. Pretend like you're writing a instruction manual for the next person. Another reason you might be reading code, because it's broken. Troubleshooting usually starts not with writing, but with reading the code. Diagnosing the issue. You might just get somebody saying, hey, the screen doesn't turn on. I mean, that may or may not be the only issue, but diagnosing what exactly is causing it and where see what changed recently, if it was a recent thing that broke, things like that. Determine possible causes. Some things, like a screen not turning on, might be caused by several different things in your code. When that is the case, it's time to prioritize. And this is where your code reviewing skills come in. Again, look through commit history, check how fast it will be to fix things, or test if it is the fix, and how likely it is. So if there's something that'll take you 30 seconds to test, might as well put it at the top of the priority list, even if it's not the most likely, just to get it out of the way and document that. And then while you're testing your fixes, remember small, frequent commits. Document what you're trying, what the results are, and why you're testing that. And sometimes you might need to write new code, whether to speed up the debugging process or to write unit tests. Because sometimes it might take a while to replicate the issue. So if you can speed up seeing the issue, you can, one, learn something about it, and two, be able to test if you fixed it faster. Another part of troubleshooting is knowing when to ask for help. There's no hard and fast rule on like how long should you struggle with something before you go and look or go and ask someone, but roughly give it a few minutes of thinking it through yourself before hitting the internet, and maybe about 15 minutes before reaching out to a team member or someone who can help. Or if you're approaching something completely new, it might make sense to ask for help right away, just to get insight from somebody who's more familiar with the problem or the technology you're using. And then if you know you're going to have a lot of questions, it might make sense to consolidate them before you go ask that person, just so you can have a full conversation about what's going on, as well as not interrupt them 15 times with every single little question you have along the way. And I wanted to point out a certain kind of question I've had problems with getting, called the XY problem. You see it often on Stack Overflow when somebody asks something that sounds absolutely ridiculous. And they're saying, how can I use X technology to solve, or X technology to solve this? And a lot of people wonder, well, why are you doing this? Or why are you doing it that way? When the question really wasn't, how can I use X? It's, what are good ways to solve the problem I actually have? If you're the one being asked and you get one of these questions that just doesn't seem quite right, or you don't understand why they're doing the thing, keep asking why until you dig to the root of the problem, and make sure they're not asking an XY problem question. So if you need to, or happy to take questions now. Otherwise, if you have code you need reviewed, feel free to reach out to us either now or later.
Hey, Bailey, there's a few questions. Do you have any suggestions for junior engineers that need to get a handle on like a large code base? I guess the idea is maybe like they don't have maybe as much experience with tools or process, or maybe even like the people skills, ways to tap into the senior engineers around them. Just kind of curious about that.
If there aren't architecture diagrams, maybe sketch them out yourself with your understanding, starting at the entry point and going from there, seeing how things are connected and get an actual drawing for yourself. That also gives you a point to start asking questions of the senior engineers, because you have something to point out and reference as you're having that conversation. Some people think of it a lot like mind mapping, but yeah, having that essentially picture of the code and how all the components connect will really help.
Nice.
It doesn't have to be pretty Visio. It can just be a literal sketch on a piece of scrap paper.
Mm-hmm. I was gonna say some things I've done in the past too has been like following like a really important call tree. Like if you're starting, like you mentioned in the setup in an Arduino, like some of the function calls are going to be not important. So it's kind of a little bit of an art to like figure out which function calls are important. But if you can kind of dive down into a couple of function calls deep to figure out like, oh, what's the ultimate kind of result of calling this function. It calls this other function, which does this other thing, which then, moves the widget. That you can kind of realize that, oh, that's why that call is happening here. And then I think the challenge with that one is just to make sure you don't go too deep and get kind of lost in like call tree hell. But when you go, if you just get kind of you have to go deep enough to get enough value, but not go so deep that you're lost in the weeds. And if you can get that balance right, then that can be a good way to kind of get an idea of where you are in the code too.
And sometimes you have to do that backwards because you'll hit a breakpoint or a bug and have to figure out how did I get here. Go the other way.
Right. That's a good point too.
Your other questions in there. Capture and learn from the result of your code reviews.
How does the organization learn, I think, from the code reviews and results that you find in them?
If you do team code reviews, that's always nice. Don't spring them on people. I've seen that happen where somebody walks in and goes, oh, that's my code. Whoops. But regular discussion that, especially if you feel like you learned something, reviewing the code with a larger team, keeping a wiki or a best practices doc. If you see something over and over again, that's definitely time to document it and turn it either into a library you can use or article you can reference for the rest of the team.
Yeah, that's a really good point. Like code style documents are built out of this, I think, in a lot of cases, some organizations. The other thing I was thinking of too was getting code beautifiers in place, because a lot of code reviews can get derailed by, I think you mentioned just stylistic types of things, like how many spaces do we have, or your braces are on the wrong line. And a lot of times that's not, like, human brains are a lot better at, or they can do that, but that's not like the most efficient use of them, And so things like Uncrustify, or I don't know, there are many code beautifiers. Just if you Google for that, you'll find automated tools, and definitely something that you can hook into your CI/CD pipeline to just run either on branches or as part of like a pre-commit hook that would allow people to kind of verify that their code matches all the style criteria before you even get into a code review, before you use anyone's brains. So that then, and the other thing is I found is that forces people to think deeper about the code. If somebody is like checking it in and they're just like 5 minutes before the code review, they're like, crap, I gotta like get through some code and find some stuff so it looks like I did something, and they're gonna find those stylistic things, right? And if you take that away, then it puts people in the mindset of like, okay, I need to spend some time with this because I know I'm gonna need to understand the code in order to really get this, provide some meaningful input to the code review. So it's another piece.
And there's some things you can automate with that too, like you said, like Crustify for style, but the documentation part, like if you have, there's actually documentation checks that say, hey, a certain percentage of your functions have to have a documentation string on them or this check will fail. So that you know that you're actually getting that documentation in there, or at least getting a nudge to finish it correctly.
Nice. What do you just kind of a riff off of that, what have you seen or found effective in terms of like how unit testing and like coverage might play into code reviews? Like, do you make that a requirement before you go into code review that you got to have a certain level of coverage, or do you feel like it improves the conversation that you have in a code review when you have unit tests and coverage? I'm just kind of curious what your thoughts are on that.
I think in your pull request, it helps to show what you were thinking, what you were doing. So show your thought process and what you thought needed tested and where things could break. But yeah, as far as documentation part of it, yeah, I mean, the test can show your thought process, but I'm not sure it's a documentation strategy though. It would definitely help have the conversation of thinking, when you're troubleshooting, what are the ways that this could break, and finding those, what could, how could this issue be caused? Things thinking of that ahead of time, you might have to do less troubleshooting in the future.
Yeah, I was just curious if you thought that the, with those in place, do you then eliminate a whole nother class of like super obvious, like dumb bugs that you then don't worry about? So that, because I mean, I think with code reviews, there's a lot of things that you can imagine could be automatically determined, and there's a couple of things that would be a couple classes of problems with code that would be really, really difficult to automatically test for. Things like architectural strategy, or building it in a way that's going to be malleable for the future, or it's going to be adaptable to future needs. It's hard to program that in, whether the code is adaptable or not. Whether it's
anti-patterns kind of deal there.
Yeah. So I was just kind of going down this riff of how do you automate away all the stuff that can be automatable so that the humans can focus on the part that really requires a human and is really difficult to automate. Any other classes of code review, like optimizations you can imagine people might make?
Putting
you on the spot here.
Yeah.
Because those are some big ones, is like stylistic changes. I think documentation, logical testing, like we mentioned. And what about even we've got static analysis or SAST and DAST tools that are also good prerequisites to a code review. That would probably.
Yeah, those will check for your security flaws or potential malicious libraries you may be using. Checking for licenses, that'd be another one you can do automatically these days. I've also seen once a variable name checker. So it had to be an actual English word somewhere in the variable, or it wouldn't pass it, or if it was too short or something. I think iterators were the only one that could get away with being like less than 4 characters or something like that.
Interesting. Yeah. Yeah, just focus on keeping it readable. Interesting. Well, cool.
I know some IDEs will actually take care of that style stuff for you. So like if one person likes looking at it one way and another, you can actually set your IDE up to display the code in a specific style, but it'll still check it in matching the style guidelines that you've automated.
Yeah, there is a standard that people have pushed out, and I'm forgetting what the name of it is, but there is a standard that folks have put together of so IDEs can all kind of look for this one file, and then editor config. So yeah, if people look for editor config, I mean VS Code does, and a number of other places do too, but yeah, I mean, sorry, and maybe this is taking it a little beyond where you were thinking with reading code and more into code reviews, but and then if improving the efficiency of code reviews, but it's any way that you can improve or reduce the number of things that humans need to do, that's in that code review, and focus them on the hard stuff. That's what it kind of is. So yeah, go check out editor config if you're interested in trying to standardize it for your department. Most there's always that one guy that uses Vim, or the one guy that uses Emacs, and it will fight tooth and nail to ever use any IDE, and I believe that there's plugins for all of them with this editor config standard. So yeah, it's great. Check that out too if that helps automate some things away from your code review.
Yeah. But yeah, being a coder is a lot more communication, both on the communicator and the communicatee side. So anything you can do to make it easier for other people to read your code, or even approach your code. So all the writing you need to do before you even get to code is important. We're at heart communicators. So, all right. Well, thank you for coming, and we'll see you at our next Lunch and Learn.